In this lecture, we will be diving into some helpful programming concepts for those that might be new to the world of programming. This would also help you to understand common coding patterns as we work through the projects in this course. Let's first talk about variables. There are different types of variables that are available for us to use. As an example, int is an integer, float is a floating point number, and an example would be 1.5 or any number that has more precision with a decimal point. Char is a single byte of memory enough to hold one character, such as an A or a B. Boolean is a value that's either true or false, and there are other types of variables such as double and long and so on, but for the most part, these are the variables that we'll be seeing throughout this course. Variables must be declared before they can be used, and in this case, we are declaring three variables. The first one is speed, and it's of type integer. Next, we have a character variable, ch, and a Boolean variable is lit. When variables are defined outside of functions, as is the case here in our program, they are referred to as global variables. We'll talk a little bit more about that later on. When variables are declared, we can define values for them. In this case, we're setting speed to a value of 0, ch equal to h, and since this is a character or char variable, we have to use single quotes for the character that we are assigning to ch. Because isLit is a Boolean variable, we can set its value equal to true. That's the basics around variables and defining and declaring their values. Another type of variable we may encounter is a constant. These are variables that do not change. Essentially, you define them once and assign them a value, and they cannot be modified later on in your program. It's a good way to protect a value or a definition that you want folks to reuse in your program, but you do not want it to be modified. At the top, here are a couple of ways that we could define constants. In this example, we use the #define keyword, and we specify the name of the variable that we want to make a constant and its value. Alternatively, we could say const, which is the constant keyword, specify the type of variable, in this case it's an integer, the name of the variable, and assign it a value. These two statements are essentially accomplishing the exact same thing. Then later on in our program, we could access the value of that variable. So, we can retrieve motor pin 2 and get the value of that variable. However, if we were to assign it a new value, look at what is going to happen when we compile our program. All right, you'll get an error saying that it's a read-only variable. So that essentially is what constants are. They allow us to define read-only values that we want to remain constant throughout our program. Let's talk about the difference between local variables and global variables. A variable that is declared globally is accessible everywhere in your program. So as an example, in this program, we have three global variables: int motor speed, float temperature reading, Boolean completed. These can be accessed anywhere in your program. So in our setup function, we can actually set motor speed equal to 10. And similarly, in our loop function, we can set that value again or read out the motor speed value. The same applies to temperature reading and completed. So hence, when variables are defined outside of functions, they are referred to as global variables, and they can be accessed anywhere in your program. On the other hand, a local variable is declared within a function in your program. So in this particular case, we are declaring a result variable, and we are setting result equal to num1 plus num2 in our calculate sum function. This result variable can only be accessed in this calculate sum function. So what that means is we could not set or retrieve result in our loop function. since it can only be seen within the boundaries of this calculate sum function. So that's a local variable. So to summarize, the global variables are defined outside of functions and are accessible anywhere in your code, and local variables are defined within functions and can only be changed and accessed within the particular function itself. Next, let's talk about arrays. You could think of arrays as just a way to perform groupings of variables of the same type. Really, they are a collection of variables of the same type. So as an example here, we're defining a pinout array, its subtype integer, and we're specifying that it has values of 1, 3, 5, 7, and 9. Alternatively, we could have specified the pinout array in this manner. Here we have integer pinout 3. What we're saying essentially is the size of our array is 3, meaning it can hold 3 specific buckets of integers. And to define the values of those buckets, we say pinout 0, meaning the first bucket is going to have the value 1. Pinout 1, which is the second memory location, is going to have the value 3, and pinout 2 is going to have the value 5. So this is a longer way of defining the values of the array, and this is a shorthand way of actually declaring the pinout array and defining values all in one line. You have to remember that individual array elements are identified by an integer index. So if 3 is the size of your array, the first integer index always starts at 0. So to access or set or retrieve the first element, we refer to it as pinout 0 equal to whatever value. One thing to remember is that if the size of your array is 3, 2 would be the maximum value that you can access. So if you specify pinout 2, that's the last member of your array. If you do pinout 3 and try to access that value, you'll get an out of bounds exception occurring because remember, arrays start at 0 or the first member of the array is the 0 index. Here's another example of defining a character array. So here we have character temp display and we specify an actual string which would be stored in the array. Another example you might see is a multi-dimensional array. What this means is that we can store each of these are the size of this particular array is 10, which is the first dimension, and the second dimension is the number of individual characters, or in this case bytes, that are stored in each row for the array. So we have 10 buckets that go from 0 to 9, and within those individual buckets we can go from 0 to 7 bytes. We'll see the use of this byte array when we look at our 7-segment display project. Next, let's talk about the concept of looping. Looping simply means performing an action again and again based on some criteria. The first type of loop we'll look at is a for loop. And in our for loop, we are essentially saying that we want our loop, in this case, to execute 10 times. Here's the syntax for a for loop. So initially we have for, we specify a starting integer, int I equal 0, so we're starting at 0. At the end of our loop, the condition for that when we jump out of our loop is that I has to be less than 10. Once I is equal to 10, we exit our loop, I++. That means that we want to increment the value of I, which with each iteration, we simply print out the value of I. So when this is run, it's going to display 0, 1, 2, all the way to 9 on a new line. In this case, we do for int I equal 10, we start at 10, I is greater than or equal to 0. That means that we want to run this, and of course we're decrementing I minus minus. First we will see the value 10 being displayed, then when we loop around, I is decremented, the value now becomes 9. Is 9 greater than or equal to 0? Yes. Then we decrement to 8. Is 8 greater than or equal to 0? Yes, and so on until we get to 0. So this will display 10 to 0, and then when we decrement 0 to minus 1 is not greater than or equal to 0, so we would exit our loop. That is essentially a for loop and how it works. Another type of looping construct is an if-else loop. This is what it looks like. Essentially, we are checking for a particular condition. If digital read on our button pin is low, we perform this action, and the action actually is defined within the curly braces. Else, if this is not the case, and of course digital read of button pin is high, we would perform this alternative action that's defined within these brackets. So you could think of an if-else loop as a Boolean check if a particular condition is true, or whatever if expression we evaluate in the brackets equates to true or false. Once that's met, we execute this bit of logic. Else, we execute an alternative piece of logic. An if-else statement can also be nested with several conditions. So in this case, we're checking if state is equal to 0, we perform this action within these curly braces. Else, if state is equal to 1, we perform this action. Else, if state is equal to 2, this action. Else, if state is equal to 3, this action. And if all else fails, we can have a final else check where we, if none of our conditions are met, we jump down into this else final else block, and here's this logic would be executed. This is called a nested if-else statement. The next type of looping construct we may see is a switch statement. You can think of a switch statement as providing a clean way to organize and present conditional logic rather than having multiple if-else statements. Here's what a switch statement syntax looks like. Essentially, we would have the keyword switch with the expression we want to evaluate, and then we run through several scenarios of if the case, if expression is item 1, meaning the value of expression is item 1, we execute this logic and then we break out of our switch. If it's item 2, we execute this logic, and so on. Let's look at a practical example of a switch statement. Here we define a reading int reading equal to 3. We do a switch passing in that reading variable, and we evaluate several different options. In the first case, if the value of reading is 1, we would execute this logic and then break out of our switch statement. In our case, the value of our reading is 3, so neither case 1 or case 2 would be executed. However, since the value is 3, we would jump into here, and reading is 3 would be displayed on our output terminal. We would then break and exit out, and we would be done evaluating our switch statement. So as you can see, it's just a different way of doing a multiple if-else check, but in a more clean, concise, organized way. If, for instance, our reading was 5, it would no longer be equal to 1, 2, or 3. So if none of these conditions are met, a switch statement would ultimately jump down to the default option, and it would print out, in this case, reading is not valid. So you should always include a default option with your switch statement to tell the program how to behave if none of your conditions are met.